Hello, welcome. Let's try to solve another Leetcode problem. And this problem is going to be my calendar 3. And let's first try to understand it. So the K booking, we need to understand what is K booking. So it happens when K events have some non-empty intersections. There is some time that is common to all K events. Yeah, so let's first try to understand this one. So we have K events. And if there are intersections, so this means for this kind of event, the case would be equal to 2, because at these areas there are some intersections at these areas, right? Yeah. So we are giving the start time and end time. After this given event, return an integer k representing the maximum k booking between all the previous events. So this previous is confusing. Definitely we don't need it. That is just between all the events. Yeah, all the events, it means this one and before it. But if it is said previous, maybe this one is not included, so it is confusing. It should be all the events. So we're gonna implement the my calendar 3 class. So this is just initiate object, and then we're gonna just check the book, and there will be 400 calls. Yeah, if this is something like the range from the start to end, normally we're gonna think about it the difference array, but the start and end place is gonna be 10 to the power of 9. It means it is not possible. But we're gonna use the sweep line method. The sweep line is similar to difference array. Yeah, but it can reduce the time to just 400 calls. So if we are giving this kind of event, yeah. So for example, if we are giving this kind of event, we're gonna just separate the start and the end positions. Yeah. According to this problem, if there's an overlap, for example at this dot, let me make it clear. So this is the event, and this is the start and end, and there's another event. So this start and this is end. Yeah, and what is the k value? So as we can see, there's a duplicate. But according to the description, so for this kind of a result, it is 1. It is not 2. Yeah, because it is not said from the description, but according to the examples, normally it should be said about this kind of edge cases. But according to the description, they just make it like that. So while we are preparing the sweep line, we should be careful about it. So for example, let's just try to check. So for example, 10 to 20, this is a 10, and this is 20. So for another one is 50 to 60, that is okay. So 50 to 60, and another one is 10 to 40. So this is 10 to 40. Yeah, and another one is 5 to 50. And here gonna be 5 to 15. Yeah, and then we're gonna check 5 and 10. So this is 5 and 10. So normally we're gonna check this dot 10. So for this 10, actually it is not 4, it is 3. There are 4 duplicates, but this is just the end prison. So the end prison will go first, and then we're gonna have this start prison, and this start prison, and this prison is just in between. So it means it's gonna be 3, not 4. Yeah. Now we're gonna design the sweep line method to solve the problem. So we're gonna prepare self dot. Let me just use the events. We're gonna prepare an empty array. Now we just want to put it inside. So self dot events should append. Now for the start time, we're gonna prepare it with positive 1 or negative 1, because the end time will always go first. So it means here will be a positive 1, and self.events should append the end time with a negative 1. Yeah, because the end time will always go first before the previous end time will always go first before the current start time. Now we want to sort it. So we're gonna sort the events, and we want to check the start, the value and the sign. So this x value just means it can be a start or add precision, but it depended on the sign. So inside the self.events. So if this sign is equal to, yeah, so according to our question, if it is equal to 1, it means it is the start. So it's going to be the count plus 1, and the result going to be the maximum of the result and the count. Otherwise, we're going to set the count minus 1. And finally, we want to return the result. Now let me just define the result and the count. So it's going to be 0 and 0. So this is going to be the entire code. As you can see, there's no. Oh, so here is the sorting. I expected there will be no sorting, but definitely we need a sorting. Let me analyze the time complexity. Basically, there will be sorting, but if there is a sorting, it means there will be 400 calls, of course. And for each of the call, as we have a sorting, so this is going to be n log n. Yeah, so this means it is 400 times 400 log 400. So this is going to be the time complexity. So we're going to call it n squared log n time. Yeah, because for each of the call, we still need to sort the events array. Yeah, so after appended inside, we still need to sort it. But I think we can use some advanced data structure to reduce the time complexity. Maybe just to, let me think. Yeah, maybe it's just to 400 log n time. It's not 400 squared, 400 log 400 n log n time. We can reduce n, but currently it is n squared log n. Now let me just run it to check. As you can see, it works. Now let me submit it. Yeah, as you can see, it passed all the testing cases, and it's pretty fast. Maybe we can still, I'm not sure, but let's just have a try. Maybe we can optimize the time a little bit. We can use the sorted list. So from the unsorted containers, we're gonna import the sorted list. So we're gonna prepare the self.events gonna be equal to sorted list. Now we just need to add it inside, right? And add it inside. And after add it inside, we don't need to sort it because this is a sorted list. It has already been sorted in increasing order. Now, as you can see, there's no sorting, and the time complexity would be n log n. N is just 400 calls, and for each of the log n, we're gonna check that n gonna be 400. Now let me just run it to check. Let me check if there's something wrong with it. It seems it is okay. Now let me submit it. Yeah, as you can see, we cannot compare if the speed improved or not, but maybe that is just because of the testing data that is not so large. If there's a large testing data, definitely this will be fast. Yeah, because basically, as you can see, this is just n log n time. And that n is just 400 calls. Yeah, so if without using the sorted list, it's going to be n squared log n. So thank you for watching. See you next time.